Determine the moisture content of the given soil sample. The moisture content of soil, also referred to as water content, is an indicator of the amount of water present in soil. Moisture content is the ratio of the mass of water contained in the pore spaces of soil, TOTHE solid mass of particles in that material, expressed as a percentage. ASTANDARD temperature of 110 plus or minus 5 degrees Celsius is used to determine the mass of the sample. Almost all studies of soil tests determine the natural moisture content of the soil, and it is essential knowledge for all studies of soil mechanics. The natural moisture content provides an idea of the state of the soil in the field. Moisture content is one of the most important index properties used for the correlation of soil behavior and its index properties. The moisture content of the soil is used to express the phase relationships of water, air, and solids in a given volume or weight of the material. For cohesive soil, the consistency of a given soil, along with its liquid equipment, NONCORODIBLE container, vented, thermostatically drying oven that maintains temperatures between 105 degrees to 115 degrees. Balance of sufficient sensitivity, sensitive to 0.01 G, container handling apparatus. 1. Clean, dry, and weigh. 1. The container. The balance needs to be tarred before it is used to measure the weight. 2. Weigh W2, a sample of the specimen in the container. 3. Keep the container in the oven for 24 hours. Dry the specimen to a constant weight, maintaining the temperature between 105 degrees to 115 degrees. The time will vary with the type of soil, but 16 to 24 hours is usually sufficient. 4. Record the final constant weight, W3, of the container with the dried soil sample. Peat and other organic soils should be dried at a lower temperature, approximately 60 degrees Celsius, for a longer period of time. These are the data that we have gathered from the experiment. Each soil samples from different depths have their own computed moisture content. The moisture content ranges from 20% to 30%. This is the formula used in determining the moisture content of each soil samples. In order to get the moisture content, we need the weight of can plus wet, weight of can at dry, and the weight of the can. Conclusion. The experiment determined the moisture content of soil samples from different boreholes using ASTM D2216 oven drying method. The test showed that soil moisture content varies with depth and is an important property affecting soil behavior, strength, consistency, and compaction. The elaborado procedure also helped in understanding the relationship between water content and dry soil mass. Moisture content is an important index property of soil because it affects the engineering behavior of soil, such as strength, consistency, compaction, and compression. Through this laboratory test, the relationship between the mass of water and the dry mass of soil particles was determined using standard laboratory procedures and calculations.